Quadratics of roots of quadratics, sorry. So let's just dive right into this warm-up. It's a pretty simple warm-up. You're given a quadratic that's shown, and it's going to ask you what the maximum is, and in this state question, the only thing you have to do is literally say what the y value is, which happens at the vertex of the maximum. So this y value is 1, 2, 3. So your answer would just be 3. All right, so just to talk about this question real quick and what we're doing. Back in probably unit 4, we did stuff with roots, okay? And we did stuff with, it was more with like functions. So I'd have a graph, and we would graph a line, and I would say, what is the root of that function? What's the zero? What's the zero of that function? And the zero would be wherever it crosses the x-axis. So let's say that was -1. The answer would be -1. Okay, we're doing the exact same thing today. So if I asked you what the root was of this question, I'm asking where does it cross the x-axis? And it crosses here, and it crosses here. So you'd have 2 answers. Remember I talked about linear functions have at most 1 answer. Now quadratics have at most 2. So we have -1 and 1, 2, 3. So that's all we're doing today, not too bad. Okay, so there is a definition down here. So go ahead and I'd pause the video and write it down and then restart the video with what I'm doing. So because I want to dive right into the solutions. Okay, there's the definition of roots. We just talked about that. I guess the one thing I do need to cover is that roots, solutions, and x-intercepts are different ways. So to say that there's a bunch of different, ooh, I shouldn't have put roots here. I need to put zeros. Zeros. That's the big one. That's a big one. Okay, so there's at most 2 solutions like I talked about up here. And the reason is because the power will tell you the max amount of solutions. Okay, so a max amount of solutions are 2. So this would be an example of 2 solutions. It crosses here and here. 1 solution would be if it just touches the line, like it bounces off of it. And it can go either way. And then no solution means it will never cross the x-axis. Okay, so there's 2 solution, 1 solution, or no solution possible. Solutions possible, I guess I should say. Okay, so if we look at number 1, what are the solutions? And I want to use a highlighter, it's hard to see. So it crosses here, and it crosses here. Okay, so that's 1, 2, 3, 4. So we have the x value of -4, and we have to put it in the braces, not coordinate points, because coordinate points or in parentheses, because that means it's a coordinate point, and 1, 2, so that's our other solution. So this has 2 solutions. If we look at number 2, it crosses here and here, and that kind of just highlights one big highlighter mark. So we have 1, 2, 3, 4, 5, 6, that's 6, and then 7, 8, so 6 and 8. Okay, so that's all you're doing in this daily practice or in these notes. So I'm going to graph number 3 and number 6, because apparently, actually I lied. We're going to do 3 and 4 in the notes. I don't think we need more than that. So this will just practice us with how to graph them, and then we'll actually find the solutions on here. So let's just do 3 and 4, and we'll just call the notes short here, because I think this is all you need. So if you remember with graphing, the first thing you need to do is find the axis of symmetry. So you have x equals -b over 2a, correct? So again, with what a, b, and c are, a is the x squared, b is the x, and c is the number, or what's in front of that. So a is 1, b is 4, and c is -5. So we plug it into here, we get -4 over 2 times 1, which ends up being -2. You're going to notice these tables are bigger, and they're bigger because we have to keep graphing until we hit a 0. So just keep that in mind. Second step is to find the vertex. So we plug in that -2 into here. So we have -2 squared, and then 4 times -2 minus 5. So that gets us 4, -8, and minus 5. So that gets us -4 minus 5, which is -9. So we're at -2, -9. Okay. So from here, we're just going to fill out the table, and I'm going to need room because I didn't really leave you room for that. So I'm going to kind of separate my work. Okay. So let's do -1, 0, and 1, and then -3, -4, -5. I'm just going to do these points. Since the axis symmetry, they all should be the same. And since this does, and I didn't ask this, if I ask you if this opens up or down, you would tell me it's up because this is positive. So these values should be increasing. Okay, so if you plug in -1 into here, we would get y is going to equal -1 squared, which is 1, 4 times -1, which is -4, and minus 5. So that is -3 minus 5, which is -8, which means this would be also -8. If we plug in 0, this one's the easiest. 0 squared is 0. 4 times 0 is 0. So y would equal -5. And then if we do x equals 1, put little lines underneath this. 1 squared is 1. 4 times 1 is 4, and we have minus 5. So that gives us 0. So we have -5 and 0. Okay, so if we plot these points, at -5 it's 0, at -4 it's -5, and at -3 it's -8. Let me just do the flip of that. -1 is at, oops, missed that, messed up. Meant to put it here. -1 is -8, 0 is -5, and 1 is 0. And this is not going to look pretty, but we're going to do it. Okay, so the question is, what are the solutions? Well, the solutions are where it crosses the x-axis. So right here and right here. So our solutions are x equals -5 and 1. Okay. Actually, I want to look at another example just to see something. Let's actually skip to number 6 because I think that'll be a good example to have too. So let's go ahead and do number 6, and that will be our last example. So the first thing we're going to do is axis of symmetry. The A would be -3 because that deals with the x squared. The B would be 6 because that deals with the x, and C is 0 because there's no constant. So we have x equals -b over 2a. So you plug in the negative, or the 6, and then the negative stays there. And then you'd have 2 times -3. Well, that ends up being -6 over -6, so it's just +1. So axis symmetry is just 1. So then we have to find the vertex, and we just plug in 1 into here. So we have -3 times 1 squared, which is 1, and 6 times 1 is 6. So we have -3 plus 6, which equals +3. Because this is negative, it's opening down. So these values should decrease. These should decrease. Okay. So we plugged in 1. Let's do 0 and -1 and 2 and 3. I'm going to fill in these because I think they're easier, less calculations to do. And then everything should be symmetric. I would always check it, but we're not going to because we don't need to. So we're going to plug in x equals 0. 0, or y is going to be -3, 0 squared is 0, and 6 times 0 is 0, so this whole thing is 0. So we actually found our first 0. Since that's 0, this should also be 0, and you can check me if you want, so you can pause the video and check if you need to. But we just found our solution. That's all we needed to do was to find the solutions. We need to graph it and find our solutions. So we're going to 1, 3, and then it goes down 2, 0, and then 0, 0. All right. So our solutions, and you can see it in the table, or you can see it on the graph, is x equals 0 and 2. All right, that's it for the video. Hope that helps. See you later. Bye.